to erase.
I'm seeing majority 3, some 2s, and a 5. So we'll do those 3. Right. Remember that anything translating you have to know how to do. That's not something you can do in Desmos. So for less than a number, we're subtracting some x minus 4, some variable, you put whatever you want. And then notice where the commas are in this. For less than a number, comma, cubed, then all of this is cubed. If it was for less than a number cubed without a comma, then just the number part would be cubed.
Wait. Huh?
Where's the plus 3?
Where's the plus 3?
Where's the plus 3?
And then plus 3.
Oh, this is the...
I
did almost right. I had that idea.
The for less than is yes, but because it says comma cubed, all of that is being cubed, and then plus 3 at the end. If it said for less than a number cubed, comma, then it would be x minus, it'd be x cubed minus 4, and then plus 3. But the commas make everything different. Right, number 3, we had to find the line of best fit, so you can put that into Desmos. I'm just being lazy because I don't want to type in everything. I could have like that, but cool. Works. If you typed in the table, typed in y1 tilde mx1 plus b, you would get your line of best fit. And put 3 decimal places. So y equals negative 0.503, x plus 15.733. And I'll write that down. Questions on either of those? And then number 5 could be done in Desmos just to see the slope and y-intercept, but you have to also graph this. So start at 0, 0, go up 1 to the left 4 as many times as possible, and down 1 to the right 4. But it should look something like that. Right. And then onto the SOL. So make sure you're writing these down. If you didn't have this, if it's done at home, as soon as you get home, take a picture of it. But if it's not, I'm not collecting this after today. So take a picture and email it for your previous one. Yes. Yeah. For 6C, you could have done that one in Desmos. Just put it in and just copied the graph or did the work. But you should have the graph with the y-intercept and all of the slope points. Y equals negative 2x plus 5. So start at 5, go down 2 to the right 1 every time you work all the slope points off. Right. And then go on to the next page. The next 2 pages is not something we had talked about, but I wanted you to try it. You could have looked this up, got help from someone else, got help from me about this. I'll just briefly explain what this is, but later we'll talk more about this. You're looking for which of these represents a function. If each x goes to only one y, it's a function. If not, it's not. So 1 was a function, 3 was not, 2 was not, and 4 was. And then on the next page, domain is all of your x values, left to right, least to greatest, and then your range is your y values, lowest to highest, also least to greatest. So 5 was C, and 6 was D. And then on the next page, this asks about zeros. Your zeros are your x-intercepts, so you could have put each of these into Desmos and found where did it cross the x-axis. So the x-intercepts, the zeros for 7 were 2, 0. 8 was 4, 0. 9, there were 2 of them, 3, 0 and 5, 0. 10, 2, 0. 11, 6, 0. 12, negative 2, 0. 13 asked for which one had 2 distinct zeros, so 2 zeros. And C was the only one that did that. And then in 14 through 16, if you had put that into Desmos, you got 2 zeros. You could either put them in as ordered pairs or write it as a set notation. So 14 was negative 1/3 and 3/2. 15 was negative 1/2 and 2/3. And 16 was negative 4/5 and positive 4/5. And then go on to the next page. And then the last page of this was just asking about x and y intercepts. So for 17, you could have either put that into Desmos and found these, or looked at, eliminated one of them by just looking at the y-intercept, which was 8. D was the only one that had that, y-intercept. 18, you had to plot the x and y intercepts. And 19, you could have played around with this, put 2 factors in to see which one would give you this graph. And it ended up being those 2. I'm going to show you a couple of these in Desmos, and then I'll tell you what the next section is of 2. So this is 17. Okay. I can do that. This is the one that asked about distinct zeros, the 2 distinct zeros. So if I graph all of these, there's only one that crosses the x-axis twice. So Desmos will help you in those situations. If you had put in different factors for 18, you could see which one looks exactly like that. Prior to the bell ringing, I need you to write this down on the notes that you have. Which one? Standard form. So as you're writing, I'm just going to talk through some of this stuff. So we ended our Unit 9 stuff. Now we're talking about Unit 10 stuff, which is quadratics. We have seen these, but not knew what they were called. All quadratic equations are written in the form y equals ax squared plus bx plus c. That is our trinomial that we were just factoring in the last unit. The standard form is your ABC order highest exponent to decreasing. When graph a quadratic equation creates a U-shaped curve called a parabola. So every time we saw that U, that was a quadratic, a parabola. To the best of your ability, draw this rough sketch in. If you don't get all of this done before lunch, that's okay. We'll finish up when you get back. The A value in front determines if it faces up or down. If A is positive, it faces up. If it's negative, it faces down.
So we just make it down.
Keep writing down this stuff. Make sure you get all the rest of the stuff.
That's what I did. I had to try to say it 5 million times. All these times you keep dropping me in this one. Because then you that you should have to do that one or different.
Anyone still need these graphs?
We did it.
Wait, did you get these graphs? I'll leave that up.
The most.
Oh, right.
What number is that?
10.
Because I saw that the way it's used because it makes sense. We just
Okay.
made him homework so he can, and he's freaking out because of it.
And then it's in the unit 10 graphing characteristics of okay.
I'm really good at exactly like that.
Right. We're gonna learn. So we talked about the quadratic, the parabola, the whether it faces up or down. There's also something called axis of symmetry. This is a line that basically splits the parabola in half, makes it symmetric. Or the vertical line that divides the parabola into 2 equal parts. We find this by using this formula, x equals negative b over 2a. I keep calling it parabola. Parabola. And then once we use the formula, we get some x equals a number, and that would be our vertical line that would show our axis of symmetry. Normally you don't actually draw in the axis of symmetry, you just know it's there because it would split the parabola down the middle. Something else we're going to be talking about is the vertex. So the vertex is usually on your axis of symmetry, either at the lowest point or at the highest point. This is where it changes direction. It goes from going up to going down or vice versa. So the turning point of the parabola is the vertex. It's written as x comma y. If it's the lowest point, that's your minimum. If it's the highest point, that's your maximum. So we need to know all of that information as we start to graph these. Make sure you have these off to the side as well. This and this off to the side. Alright, so we're going to go through, and you could get that later, because I'm sure you do that now. We're going to start at number 1. Oh, never mind. Same page. So I'm going to show you, or walk you through how to find the axis of symmetry, how to find the vertex, and then we're going to draw a rough sketch of this. I'm going to rewrite our x equals negative b over 2a. If this helps you, label these numbers as a, b, and c. A is the number in front of x squared, not x squared. So then how would we set up our formula? X equals negative 8 over 2x. 2 was the number 1 times 1. And if we simplify that, what would that give us? X equals negative 4. So make sure you have the x equals. That is part of it. That shows it's a vertical line. Then to find the vertex, we're going to put this x value into our equation where all of the x's are. Make sure you're using parentheses. need to see you set this up for the axis of symmetry. I need to see you set this up to start finding the vertex. Then after that, whether you do that in the calculator by hand, that's up to you. So you can either put this all in at the same time in your calculator or start to simplify it by hand. What would your y value be? -1. Excuse me. So then your vertex would be -4, -1 in parentheses. So then I kind of drew in my sketch spot, so I'm just going to do this underneath, but if you still have space there, draw in axes, x and y axes. And then you're going to draw a rough sketch of where your vertex would be. Draw in a dashed line for your axis of symmetry because it's not really there. We don't actually draw this in. And then looking at the a value, it's positive. So is this going to face up or down? Up, up. So from the vertex, you draw a U that kind of looks symmetric. Mine doesn't, but that's okay. It's a rough sketch. Any questions there? Yes,
Why
Max.
did it go up?
Why did it go up? Because this a value is positive. If the a value was negative, it will go down. Other questions? Kate?
How do you determine how steep it is?
So this is just a rough sketch, but we're actually going to talk about how to find the points and whatnot later. Go on to the next part. Next page that I should have said. So let's do number 2. Same thing. I'm going to rewrite the axis of symmetry formula up here. We're not flipping back and forth. And then let's find that for this. If you need to label your A, B, and C, do that. How would I set up this formula?
-1 over 2 times -1.
So x equals -10 over 2 times -1.
What's the point of this?
Not right now, but it helps you graph it in general. And then we're not doing that this year, but one other way to find zeros is to use the quadratic formula, and the C is there for that also. But then when you're factoring, it helps you with that. What would your axis of symmetry be if you simplified it? X equals 5. Make sure you have that x. Okay, and then if we find the vertex, go ahead and put 5 into all of your x values. And figure out what y is. What is y? 2. So our vertex would be 5, 2, and then go ahead and draw in your rough sketch. And your axis, your vertex and your axis of symmetry. Would this face up or down? Down. So from your vertex, draw a U shape that is down. Try to make it symmetric, but it's a rough sketch, so it's okay.
I went negative 5.
Questions so far? We'll do a couple more of these, and then move on to the actual graphs. 3 and 4 are similar, or we do 5. So I'll let you guys choose 3, 4, 0, 1. I'll let you guys choose between 4 through 7. Which of those do you want to see you go over? 7, okay. because then we're going to do 8 and 9. So then how would we set up our axis of symmetry formula for this? It'll be a negative 24. So if it's already negative, that's going to become a positive. You can make that plus 20. You could just put positive 24. I'm just putting them both so we see why it became that. Over times -3. What would our axis of symmetry be? -4. X equals -4. But if you didn't put the negative, or you just put one negative, your answer might be wrong because you would have made it positive, made this positive instead. So be careful there. Right, go ahead and find your y value. Use parentheses. It's 90 something. Thank you. What is your y value?
6.
Positive 6. We all get positive 6.
I don't know.
I was just going to put it all in all together. Negative 4. Okay. So if you're not sure, make sure you put that in the calculator. You don't have to simplify it like this. You can just put it all in at once. Okay, and then draw that rough sketch. Would this face up or down? Down. So then draw a U shape that is facing down. And number 8, what's missing?
The C.
The C. In this, what we're doing right now, that doesn't matter. You just have to notice that the C is missing.
Can you assume that it's 0?
The C would be 0, yes. Not that we need it here, but if you were doing like factoring or quadratic formula, then yes. How would we set up our axis of symmetry formula?
-4
Which would give us positive 2, x equals 2. And then put that into your equation to find y. What is y? Positive 4. So then our vertex is 2, 4. Draw in that sketch. Would that face up or down?
Down.
Down. Questions on that one or the previous one?
How do we face down?
Because the A value is negative. Right. And number 9, what's missing? B. So when your B is missing, you're going to put 0 also.
-0.
So -0 in the formula. So negative 0 over what? 2 times 1. But anytime you have a 0, what would this be? X equals 0. Anytime your b value is missing, your axis of symmetry is going to be x equals 0. Still show the work, but you should know that also. And then if I were to put that in to find y, what's our y value? Negative 3. So I'm going to highlight my y-axis to show that's my axis of symmetry. And then would this face up or down? Up. Any questions on how we find axis of symmetry, the vertex, or draw at least a rough sketch? You know what direction it goes, how to graph the vertex. Go on to the next page. Now we're going to actually graph some quadratics, but do some of the same things and talk about domain and range. We're going to rewrite our formula, x equals negative b over 2a. We're still using that. So here, we only have a. So if I were to set up that equation, x equals, what would that look like? 0. That is going to be our answer. How would I set this up?
X equals 0 over negative 0.
2 times. And then if I put 0 back in here, my y value would be also 0. So our vertex is 0, 0. You're going to put this point, whatever your vertex is, in the middle of this table. And then you can fill out your x values. You're going to go backwards 2 and forwards 2. And then to find your y values, you have a bunch of different choices. You could take each x value, put it into y to find each y value by hand in the calculator. Or you could use this. In the calculator, go to y equals and type in x squared. Once you have x squared, go into the table, second graph. And you're going to find the vertex and points that you wrote down and just write down those y values. So because the axis of symmetry makes it symmetric, whatever you have on one side of the vertex is going to be the same on the others. So 4, 1, 1, 4. And then you can plot those 5 points. So this will tell you exactly how wide it will be. Notice that we didn't draw in the axis of symmetry, but I can see that at x equals 0, it perfectly cuts this in half. It's symmetric on both sides. If your shape is not coming back up, not making that U shape, double check your points. Questions on how we graph the quadratic? Okay, now let's talk domain and range. Your domain, as I mentioned earlier, is your x values. And we look at that left to right. So furthest point to the left, furthest point to the right. And then for your range, that's your y values. And we look lowest to highest, or bottom to top. So when looking at these x values, if I'm looking left to right, you kind of have to imagine your domain. I see this going left, and it's slowly, slightly going left, and then going up. And it's going to keep doing that off the graph, off the page, forever and ever. Where would that start if it kept going to the left? Negative infinity. And then on the right, I see this slightly, slowly going to the right, and it's going up, and it's going to keep doing that slowly off the graph, off the page. Where would that end? Positive infinity. Your domain for quadratics is never going to change. It will always be this. In algebra 2, when you get into piecewise, it may be different because they stop at places, but otherwise it's this. Then there's one other way to write it. So this is your interval notation. I'm also going to write it in set builder notation because you may see it written like that. So it's curly bracket, x is a vertical line. And then I'm actually going to rewrite this up here because I'm not in space. Then x is weird looking e and a double r and curly brackets. It reads x is an element of all real numbers. These are saying the same thing, just in different formats. Interval notation, set builder notation. It's saying this is starting at negative infinity and going to positive infinity with everything in between. Same as this. Okay. Domain will always be the same for all your quadratics. Range is where it's different. So for your range, we're looking at the lowest value of the graph. What would that be? 0. If it helps you, you could draw in a line at your lowest point or highest point, or you could look at the y value of your vertex, because that will always be somewhere in your range. So it starts at 0. This is a closed circle, so it's going to be a square bracket, going back to interval notation. What is the highest point? Infinity. It keeps going. Parentheses. Correct. Or, in set builder notation, that would be curly brackets, y, the vertical line. This is going to start at 0 and keep going to infinity, so this everything y is greater than or equal to 0. Yes.
How is that like not? Would it be negative infinity too?
No, it doesn't go to negative infinity. It's not going down. Yes.
Did you get the one?
Hmm?
Did you get the ring?
We looked at the lowest value to the highest.
Which one would be the low? Oh, 0.
0. Other domain and range questions? Do you have a question? Okay, let's do number 2. So now we know the basics of how this works. Now we can put more things back into it. Let's find our axis of symmetry. -2 over 2 times 1. So it would be -1. X equals -1. And then put this into all of your x's to find your y value. Use parentheses. What is your y value? -1 times -1 is 1. I think y equals 4. So that vertex would be negative 1, 4. Put that in the middle of your table. Fill out your x's, go backwards 2, forwards 2. And then let's find our missing ones by putting this in. X squared 2x plus 5. Go into the table, find those values. So your vertex was at negative 1, 4, so 5, 8, 8, 5, 4, however you look at that, 8, 5, 5, 8. And graph those 5 points. I know it's going up because my A value is positive. That's a good way to check yourself. Double check your A value. And draw that U shape through it. My axis of symmetry isn't drawn, but I can see at x equals negative 1, it's cutting this in half. Splitting it, making it symmetric. What is your domain? Negative infinity to positive. It will not change. So once you've memorized that, you can answer that for every question. I am going to write both notations so that if you see it, you recognize it. Until we actually talk about domain and range. Right. Range is lowest to highest. What is our lowest value?
4.
4. And that's included, so square bracket. What is our highest value? This is higher than this, so that's not the highest. It keeps going. Infinity. Or y, it really means such that y is greater than or equal to 4. Okay, we're going to do another one, and you guys want to do, and then one last page, and then you'll have time to practice. Questions on that one before we do 3? Okay, let's go ahead and do that axis of symmetry, find the vertex of which one? 33. Yep. How would I set that up?
8 or minus 8 over 2 times negative 1.
So you could put negative, negative, or just put the positive. I was going to say something else. What would our axis of symmetry be?
Negative 4.
X equals negative 4. And then put that in for all of your x values. Use parentheses. What is that y value? So our vertex will be negative 4, negative 1. Go ahead and fill out your x's. Put that point in the middle. Put that equation in your y equals negative 8. And then go into the table and find those values. We have negative 5, negative 2. Plot those points. domain of that?
Negative infinity to
Yes. Even though it has flipped upside down, domain stays the same. It does not change. That would do it. And then for the range, what's the lowest point here? Negative infinity. So it starts at negative infinity with parentheses. Where does it stop? What's the highest point? -1. That's included square bracket. Or that would be everything underneath below -1. So y such that y is less than or equal to -1. Questions on how we graph quadratics or find characteristics? There is one more characteristic that we'll add, not next class, but the class after that, zeros. On the next page, are there anything you want to see to go over next 2 pages before we go on to the last thing we're going to do today?
No.
Yes. Yes. Okay, so then go to this page. One that says analyzing quadratic graphs. So notice the graphs are already given. We're going to be answering questions to find the characteristics based on the graph. So you'll have to do it both ways, from the equation and from the graph. So this is a lot of comparing. So look at graph A. Find the line that would cut that down the middle, that would split it in half. What is the axis of symmetry for graph A? X equals -2 for graph A, and then graph B. X equals 3. Make sure you're putting x equals, otherwise it's not an equation. What would the vertex of graph A be? Four wouldn't cut that in half. 3 would. What was that vertex? -2, -5. -2, -5. We'll answer this question in a second. What about the vertex of graph B?
3, 4.
3, 4. Right. Remember that the lowest point is your minimum, your highest point is your maximum. For graph A, is the vertex a maximum or a minimum?
Minimum.
Minimum. And then for graph B? Maximum. For 5 and 6, we know the domain of both of these is going to be what? The range, however, is going to be different. So for graph A, look at the lowest point. What is the lowest point? Y value. What is the lowest Y value? And then where does that stop? What's the highest point? Infinity. So bracket -5 to infinity. For range, what is the lowest point? What is the highest point? Okay. So I know it's going to end at 4. Lowest is -infinity. And then, so domain, you should be able to answer that question with or without a graph. Range, you need the graph. in order to see it. For 7 and 8, we're going to just identify which equation would be the right one by graphing it. But we can eliminate 2 of them. I know that graph A faces up, so I can eliminate which 2?
C and D.
C and D. And then which one do we think this might be? A or B?
B.
B. Okay, so let's put B in to the calculator. What was it? Negative, positive 4x minus 1. And then I'm going to graph it. Does that look like graph A?
Yeah.
Yes. The other one, if you put it in, it would be on this side, so that's how you would know it's not. Right. And then for graph B, that one's facing down, so we can eliminate which 2? A and B. Which one do you think this might be?
D.
I heard C and C, so I'm going to put D in because I heard that one first, but if you think C, put that one in. Negative x squared plus 6x. So I have D. Does that look like graph B? So be able to find the characteristics from the graph as well as vice versa. So you do have a delta math on this that is due next week. But this one goes back to being informative. That doesn't mean you shouldn't do it just because it's informative. It is still good practice. We are still going to take a test on this after the SOL, so practice. So for the remainder of class, Patrick, could you open that door? You could be working on the following things. Practice in your notes. Delta math for this week, which is the dividing polynomials and the mixed factoring review. Delta math for next week. Past delta math. Your SOL practice for that's due on Tuesday. Your JLabs. I still have out the Unit 9 practice quiz. If you didn't grab that or want to still grab that, the answer key is on the Unit 9 page, quiz pages on Canvas. So you'll be working on any of those things. Use this time wisely, work together, let me know if you have questions.